Okay, so this is the type of problem you would see from Section 5A. You are given $10,000 as an inheritance and decide to put it into a savings account. You find a bank that will offer 3% interest compounded monthly. What will your balance be in 10 years? So there are two formulas that we learned in Section 5A. One of them looks like this, and A is the initial amount that you're given or you're using, and then 1 plus the rate to the t represents the unit of time, and then there was another formula, and actually this could be a plus or a minus if it's decreasing. There was another formula, A, which is the initial amount, 1 plus r over n to the n t. And the difference between these two formulas is the n, and the n represents the number of times per year that the interest is being compounded. So this says compounded monthly. Put n is number of times per year. So this says compounded monthly. That means every month, which is 12 times per year, the interest is going to be added on to the amount. So what will your balance be in 10 years? The 10 years is the time. This means we're going to be using the equation with the n in it. So the initial amount, A, is 10,000. It says you're putting in a savings account. The bank that will offer 3% interest. So that's the rate, 3%. And we're going to change it to a decimal. 3% as a decimal is just 0.03. And then compounded monthly, like I wrote up there, n, that means n is 12. And then what will your balance be in 10 years? 10 is the unit of time. So we're going to plug that all in into this equation up here. 10,000 is A, 1 plus the rate over 12 to the nt. So 12 is n times t, which is 10. And then we would simplify all that. You can kind of plug that whole thing straight into the calculator, or you can simplify it one step at a time. If I simplify the parentheses for 1 plus 0.03 divided by 12, that's 1.0025, and 12 times 10 is 120. So then I can do 1.0025 to the 1/20th power. I'm going to go a bunch of decimal places. The nice part about if you just plug this whole thing straight into the calculator is you wouldn't have any rounding. It's just going to give you the answer straight out. I'm going to multiply that by 10,000, and I'm getting 13,493. And I'm going to round my answer to 2 decimal places, 54 cents. So when you see a problem that says the word compounded monthly or daily or quarterly or a certain number of times per year, this is the formula that you're going to be using. So there are other times where you're going to be using this other formula when it doesn't say the word compounded. So this problem says a car's value has been depreciating by 15% each year. The car is now worth $2,015. What is the value of the car? What was the value of the car 5 years ago? So it doesn't say anything about that it's depreciating at a compounded rate. It just says depreciating, which is going down, decreasing by 15% each year. So we are going to go back to the equation. That is A, the initial amount, 1. It's either plus or minus. In this case, we're going to use a minus because it says depreciating. That means decreasing. The rate to the t, which is the unit of time. So the A, the initial amount, we don't know. I'm just going to leave it as A because it says what was the value of the car 5 years ago. We don't know that initial amount, so I'm just leaving it as A. 1, I'm going to put a minus because it's depreciating by 15%. I'm going to change the 15% to a 0.15. That's how you would write 15% as a decimal. and then to the t, the unit of time is 5 years. And it's saying when you calculate that amount of depreciation for 5 years, after 5 years it equals $2,015. So this is how we're going to set up our equation. We don't know the initial amount we want to solve for A. I'm going to go ahead and simplify the parentheses. So this would be 0.85. 1 minus 0.15 is 0.85 to the fifth. And then I can divide both sides by 0.85 to the fifth so that I can get the A by itself. So that I can isolate A. .85 to the fifth divided by 0.85 to the fifth is just 1. And then on the other side, 2015 divided by 0.85 to the fifth, we get 4,541.3. So $4,541.30 would be the value of the car 5 years ago. It's a good idea just to double check to see if this answer works. So I'm going to plug that initial amount back into the original equation, 4541.3, 1 minus 0.15 to the fifth, and then just simplify that, and it ends up equaling, I'm going to type it in the calculator, 2014.99, so we're just a tiny bit off because the answer's been rounded at the end. So it works, we just want to double check. It's always a good idea to do that. So then this is our answer for the initial amount.